Okay, students, welcome to lecture number 12 for electronic system design. And this will be the last lecture before Christmas time and before the exam. So hopefully I'm able to share some stuff with you that might help you in your exam. I have uploaded, or not uploaded, I've created a blog post on the Moodle page. It's a new blog, and I welcome your comments on anything that you want to cover there. I do not guarantee to be very fast in responding, because at the end of this week I go on holiday, so I may not be able to access everything as easily as normal. But please post any problems and you have there, because some of your classmates might be able to help you. What I want to do today is I want to continue looking at past exam papers. And just so you're aware, you have access to these exam papers on the University of Glasgow library site. So if you go onto the library for the University of Glasgow, you can access the past exam papers from there. So last week we looked at question 1 from the 2017 exam paper, and this week we'll look at question 2 and hopefully question 3 if we get time to do it. I'm recording this, so I will edit it and upload the information later. So you can revise this later if there's any problems with the audio or the video quality. I've uploaded last week's lecture, so you should be able to use that. Question 2 is a classic question based around instrumentation amplifier. And we have up here a part of an instrumentation amplifier, and it's the second part, the difference amplifier around the instrumentation amplifier. It's defined as having 4 resistors, all of value nominally R, and it gives the tolerance of the resistors. So delta has a value of 2T, which is twice times the tolerance, and asks you to prove that the difference gain is 1 and the common mode gain is delta upon R. So let's have a little look at that question there, and I shall. Okay, so hopefully you can all see that, and I will try to remember to make sure I scroll up at the proper time when I do it. So question 2 is the instrumentation amplifier, and for the case of the explanation, I will draw in the circuit so we know what we're referring to. And we've got R plus delta, R minus delta, R and R there and there. And we have V out there. We've got ground there, and this one here is V in plus. And this one here is V in minus. So that's just a quick redraw of the circuit. So we are asked to prove a diff, in other words, the differential gain equals 1, and a common mode, the common mode gains, equals delta over R. So first of all, make some assumptions and state them clearly. So assume a diff is approximately 1. We'll come to prove that in the later, because all the resistors are all equal, or at least they're approximately equal, apart from a small tolerance here, which is and to do this problem, we must calculate a diff and a common mode separately. So 1 for differential gain. First of all, let's establish what our input scenario is. So let Vn plus equal minus Vn minus, and we'll let that equal to Vdiff over 2. So what we're saying there is that this is Vdiff, and we have Vdiff upon 2 positive in that direction, and we have Vdiff upon 2 negative in that direction. So it's based around a nominal 0 volt point. So analyzing at the inputs, because of virtual earth, V plus equals, and V plus is that voltage there, Vdiff upon 2 plus ref minus Vdiff upon 2 into R1 or R over R plus delta. And V minus, which is that voltage there, equals minus Vdiff upon 2 plus sense plus Vdiff upon 2 into R over R plus R minus delta. So we're working out the effect of this potential divider on one side and this potential divider on the other side. Due to virtual earth principle, V plus must equal V minus, Vdiff upon 2 plus the reference minus Vdiff upon 2 times R over R plus delta plus R plus delta must equal minus Vdiff upon 2 plus sense plus Vdiff upon 2 into R over R plus R minus delta. So all we've done is we've plugged the two equations together. And I'm not going to do the algebra of sorting that out. I'll leave you to do that yourselves as an exercise for the student. But since delta, which is a tolerance, is much, much smaller than R, it's usually 1 or 2%, then R over 2R minus delta approximates to R over 2R plus delta, which is approximately 1 over 2. Because delta is small, this is approximately a half, slightly less than a half because delta is small, and this is approximately 1 over 2, but slightly more than one half. So V minus Vdiff upon 2 equals sense minus ref times 1 over 2, which simplifies to Vdiff equals sense minus ref. And we know that that equals V out in our diagram up here. And we know that that equals 0 in our diagram up here. So we have Vdiff equals V out. In other words, it has a gain of 1. So that's part 1, or the first part of this question. And we've got that's a calculation for the difference gain. Now common mode gain. At op-amp inputs, V plus must equal V minus, virtual earth principle, and Vn plus equals Vn minus in this case. And we'll call that equals VCM, the common mode voltage. So in the difference case, we had Vn plus was equal and opposite to Vn minus. In the common mode case, we say that Vn plus is equal and in phase with Vn plus. And we call that VCM. VCM plus ref minus VCM, plugging into the same equations into R over R plus delta must equal VCM plus sense minus VCM into R over R plus R minus delta. This part here is V plus, the positive input of the op amp, and this part here is V minus, the negative input to the op amp. So if we simplify, ref minus VCM into 2R minus delta must equal sense minus VCM into 2R plus delta. So 2R into ref minus sense plus delta into ref plus sense must equal 2 delta times VCM. And again, since delta is much smaller than R because it's a tolerance, then 2R into sense minus ref approximates to VCM times 2 delta. The common mode gain is the output voltage, which is sense minus ref, divided by the common mode input voltage, VCM. And that's the definition for common mode gain. Therefore, ACM, common mode gain, approximates to 2 times delta over 2R, which equals delta over R. So here we've proved that our common mode gain is dependent on the matching of the resistors, which is delta. And as you remember, delta equals 2 times T, where T is tolerance. And our differential gain is there. So that's our two solutions there. We have a differential gain of 1 because if ref is equal to 0, it's joined to the ground. V out is a sense pin, so V diff is equal to the output pin. And the common mode gain here, ACM, is delta upon R, where delta is 2 times the tolerance of the resistors. Okay, so that's part 1 of the question. And for that, you get 10 marks.